let's do some circular motion review. You will always get a chart like this, the standards of, the mass of the Earth, the mass of the Sun, the radius of the Earth, radius of the Moon, etc. The distance between the center of the Earth and then the center of the Earth-Moon system. I don't have these memorized. I don't expect you to have them memorized. But I do expect you to know that in circular motion, we assume everything moves in a circle, and it's moving with a radius r, and at any point, all right, you have a velocity that is tangent to your curve, and you have an acceleration that is pointing to the center, and that is called your centripetal acceleration. All right, you need to make sure you can calculate the period is the total time, T-I-M-E, divided by your number of revolutions. The frequency is the number of revolutions divided by the total time. If you have one of these, you can also remember that period is just 1 over frequency, or frequency is 1 over period. Never real sure which form of the formula I'll give you, but you can use either one of those. You need to know when an object is moving around a circle, the speed it's traveling is 2 pi r divided by the period. And of course, your centripetal acceleration is v squared over r. The centripetal force is, of course, MAC, or you can write it as mv squared over r. That either way, it's fine. The trick with this is you have to remember, in this unit, everything equals centripetal force. So if I have a rock on a string, okay, of radius r, then the tension in that string is going to equal mv squared over r, where m is the mass of the rock, v is the speed of the rock, and r is the length of the string. Because think about it, if this is your length of your string, and you spin it around a circle, that's your radius. Now, suppose you are a car, okay, and friction is what's causing you to go around in a circle around the curve. And that friction has to equal Fc. Remember, your frictional force is is mu times mg, and this has to equal mv squared over r. Now notice, friction is mu mg, Fc is mv squared over r, but the masses are going to cancel. So you'll wind up with a form of the equation mu g is v squared over r. For that, you can solve for r, v, or mu. G is, of course, you remember this, acceleration due to gravity is 9.8 meters per second squared. The other thing you will deal with is orbits. Okay. You may look for the weight, Fg. This is just big G, m1, m2, divided by r squared, where big G is another one of these constants you'll be given, 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. It's a constant. This is the mass, the two masses, and then the radius. Or excuse me, this is not orbits. This is just Newton's gravitational attraction. When there is an orbit, then we'll be setting Fc equal to Fg, or the mass of your satellite times the velocity of the satellite squared divided by r has to equal big G, the mass of the planet, velocity is mass of the satellite divided by the radius squared. Now what's interesting here is the satellite stuff will always cancel. So v squared over r is always going to equal gravitational constant, mass of the planet, divided by r squared. My pen's messing up. Sorry about that. Let's do a couple problems. Okay, well, my pen is really giving me issues. Let's go back. What is the direction of the centripetal force on an object in uniform circular motion? And the answer is it's to the center, always. What's the direction of centripetal acceleration? Well, it's also to the center. If you have to explain why, Fc is equal to MAC. The force has to be in the same direction as the acceleration, or the acceleration has to be in the same direction as the net force. What causes a tin can whirled on the end of a string to move in a circular path? Well, folks, it's a string. All right. If it breaks, what causes it to move in a straight line path? Inertia. Inertia of the tin can. A can on a string takes 5 seconds to revolve 3 times. What's its frequency? Okay, 5 seconds. This is your total time. Revolve 3 times. This is the number of revolutions. So, frequency is the number of revolutions divided by the time. So, my number of revolutions is 3 divided by 5 seconds. So this is 0.6 Hertz. What's the period of the can? The period, I can do it as 1 over the frequency. So it's 1 over 0.6 or 1.667 seconds. I can do it that way, or I can say the period is the total time divided by the number of reps. So the total time is 5 seconds divided by 3, or 1.667 seconds. Either one is right. Now, what is the period and frequency of the Earth's rotation based on a 24-hour day? All right, so let's see. The time is 24 hours. Now, how many times does the Earth rotate in 24 hours? Well, that's just number of reps. It's just once. So, the period is the total time, which is 24 hours, divided by the number of reps, which is 1. Now, I have to get this into seconds. So, 1 hour is 3,600 seconds. Multiply straight across, and I get 86400 seconds. Now, to find the frequency is 1 over period. So, I don't want to redo this. It's kind of a hassle. So this is 1 divided by 86400 seconds. And I get 1.16 times 10 to the negative 5. And of course, units for frequency are Hertz. What is the period and frequency of the Earth's revolution based on a 365.25 days in a year? Okay, so the period is 365.25 days. And we do it once a year. So my number of reps is 1. So 1 day is 24 hours. And 1 hour is 3,600 seconds. Multiply straight across. 365.25 times 24 times 3,600. And I get 3.16 times 10 to the 7th seconds. Again, to find the frequency, the easiest way to do this one, frequency is 1 over period. So the frequency is 1 divided by 3.16 times 10 to the 7th seconds, or 3.2 times 10 to the negative 8 Hertz. Now, if you're doing this on a test or a quiz, you don't want to type everything back in. So if you've got on your calculator 3.16, and it'll say EE, but I'll just put times 10 to the 7th, all right? And you want to get the frequency, you want to look for a button that has X minus 1. This button right here will take the inverse or do this process right here for whatever is right in front of it. So try that. See if that works. What is the period and frequency of a horse on a carousel that takes a minute? Okay, a minute is a time, so my time is 1 minute. And I'm going to go on and convert this to 60 seconds because I can do this in my head to revolve twice. So the number of reps is 2. So the period is the time divided by the number of reps. The time is 60 seconds. The number of reps is 2. So the time for 1 revolution is 30 seconds. The frequency is the number of reps divided by the total time. So let's see, that's 2 divided by 60, or 0.03 Hertz. Now, what is the tangential velocity for the can in problem 3 if the string is 1.4 meters long? I just brought over that the frequency was 0.06 Hertz and the period is 1.667 seconds. So, R is 1.4 meters and the period is 1.667 seconds. So we're looking for velocity, and the velocity is 2 pi r divided by your period. So this is 2 pi times 1.4 divided by your period, which is 1.667. Now to do this, you need to multiply straight across. So you actually want to put in your calculator 2 times pi times 1.4, and that will give you a number of 8.796459943. It's a big number. Just leave it in your calculator. I'm just showing you what I got. Divide that by 1.667. Just hit the divide, 1.667, and you get 5.277 meters per second. What is the centripetal acceleration of a plane in a circular path with radius of 2,500 meters, which takes 60 seconds to complete the circle? All right, so my radius here is 2,500 meters. And it says it takes 60 seconds to complete the circle, and that tells me, lost my pen, that the period is 60 seconds. There are a couple of ways to do this. Let's do this by finding the centripetal velocity, or by finding the velocity first. The velocity is 2 pi r divided by the period. So this is 2 pi, the radius is 2,500 meters, divided by the period, which is 60 seconds. So I get a velocity of 261.799 meters per second. So my centripetal acceleration is v squared divided by r. So this is 261.799 squared, don't forget that square, divided by r. So 261.799. When I square that, I get a really big number, and I forgot to put my r here, didn't I? Let's see. Let me fix that. Let me erase it. Teachers make mistakes all the time. There's 2,500. So this becomes 68538.7164 divided by 2,500. Or, when I divide this out, 27.42 meters per second squared. Now, it's entirely possible to do this without finding the velocity. Let me show you how. All right, I know your centripetal acceleration is v squared divided by r. Now, I'm going to take this velocity formula and I'm going to plug it in. Now, this is going to get a little messy, so hang on. This is 2 pi r divided by t squared. So this is v squared divided by r. That's the same thing as 1 over r. Now let me multiply this out. To do squares, you just scribble this square to everything. So 2 squared, 2 times 2 is 4. Pi squared, r squared, divided by the period squared, and this is times 1 over r. So one of these radii cancels, so that's just, you're just left with 1 there. So this becomes 4 pi squared r divided by the period squared. So this is 4 pi squared, r is 2,500 meters, divided by the period squared, which is 60 seconds squared. And if you do that, you see you get 27.42 meters per second squared. You get the same answer. Do whichever way you're most comfortable doing. What's the centripetal acceleration of an object moving in a horizontal circular path of radius 20 meters? So r is 20 meters, and the speed is 18 meters per second. All right, AC is v squared divided by r. So this is 18 meters per second squared divided by a radius of 20 meters. Go on and multiply this out if you need to. 18 squared is 324 divided by 20, or you get an answer of 16.2 meters per second squared. An automobile travels around a circular track of radius 120 meters. So r is 120 at a speed of 2.5 meters per second. What's the centripetal acceleration? Well, the centripetal acceleration is v squared divided by r. V is 2.5, and we're going to square that, divide by 120. Now, 2.5 squared is 6.25, and I'm going to divide that by 120, and I get an answer of 0.52088. So let's just call it 0.052. 0.052 meters per second squared. A mass of 1.5 kilograms, so M is 1.5 kilograms, moves in a circular path with constant speed of 3 meters per second. V is 3 meters per second. On a horizontal frictionless surface, the mass is held to a circular path by a light cord that is 2.4 meters long and has one fixed and the other is attached to the mass. Find the tension in the cord. All right, so it's this case right here. It's moving around in this lovely circle. And we're going to pretend like that's a real circle. The tension is equal to mv squared over r. So the mass is 1.5 kilograms. V is 3 meters per second squared, divided by a radius of 2.4 meters. Now, 3 squared is 9, so we're just going to go on and do these steps. 1.5 times 3 squared is 9, divided by 2.4. Now continuing to multiply across, 1.5 times 9 is 13.5, divided by 2.4. Now 13.5 divided by 2.4 is 5.63 newtons. You do not have to show me these intermediate steps. You can go straight from here to here, but be careful with your calculator. Now, we have an automobile of mass 1,500 kilograms. So M is 1,500 kilograms. Moves in a circular path of radius 20 meters on a horizontal road at a speed of 12.5 meters per second. Now, I'm telling you he's doing 72 miles per hour, so he's really trucking it there. What's the static friction between the tires and the road? Okay, the static friction is the force holding it on the road. Okay, this must equal the centripetal force. So, Fc has to equal his friction, has to equal mv squared divided by r. So this is 1,500 kilograms. His speed is 12.5 meters per second. And that has to be squared. I almost forgot to do that. Divided by the radius of the curve, which is 20 meters. Go on and square the 12.5 first. And I get 156.25. Let me do this first. 1,500 times 156.25 divided by 20. Now 1,500 times 156.25 is, oh, this is an ugly number, 234,375, and that whole thing is divided by 20. And lo and behold, I did get what the answer said, 11718.75 newtons. Now determine the centripetal force acting on a 40 kilogram child. So this is my mass, who makes 10 revolutions. So the number of revolutions is 10 around the cliffhanger in 29.3 seconds. So this is my total time. And the radius of the barrel ride is 2.9. Now, the first thing, I gave you revolutions and time. So the first thing you need to do is find the period. The period is the total time divided by the number of revolutions. The total time is 29.3 seconds divided by 10. Well, this one's easy. 2.93 seconds. So there's my period. And we're looking for centripetal force. Fc equals mv squared divided by r. So let's see. Mass is 40 kilograms. The speed is, oh my gosh, I don't have the speed. Y'all don't let me get ahead of myself. As soon as I get here, I realize I need the speed. So let me erase this and calculate the speed for you. V is 2 pi r divided by the period. So it's 2 pi, what was my radius? 2.9, 2.9 meters divided by the period, which I just found to be 2.93 seconds. All right, let's multiply this across. 2 times pi times 2.9 is what? 18.22 divided by 2.93 seconds gives me a speed of 6.21885 meters per second. Now this is too many sig figs, but whenever you're doing intermediate steps, go on and carry everything along. Don't round. So I have the speed. So I want the centripetal force. Fc is mv squared divided by r. So the mass is 40 kilograms. The speed is, let's see, I just found to be 6.21885 squared divided by my radius of 2.93. Okay, go on and multiply 6.21885. Go ahead and square that, and you get 40 kilograms times 38.674095 divided by 2.93. All right, multiply the numerator, the 38.67 times 40, and I get 1546.9638 divided by 2.93. Okay, so 1546 divided by 2.93 gives me 533.4. On this one, I get 4 newtons. Ah, that's close enough. We did some rounding. If a car travels in a circle at a constant speed, what's the direction of the net force? Well, it's always to the center. Always. What's the name of the net force for any circular motion problem? Centripetal. Remember, there is no such thing as centrifugal. So anytime you have a multiple choice question and the word centrifuge is there, the answer is no, that's not the real force. It's always your centripetal force. Now, a Lincoln Continental and a VW Beetle make a turn. The Lincoln is 4 times more massive than the Beetle. So the mass of the Lincoln is 4 times the mass of the Beetle. If they make the turn at the same speed, so the velocity of the Lincoln is equal to the velocity of the Beetle, how do the centripetal forces compare? Well, the centripetal force on the Lincoln is the mass of the Lincoln times the velocity of the Lincoln squared divided by the radius. Now, they're making the same turn, so the radius of the Lincoln equals the radius of the Beetle. So, tell you what, let's just call this, let's see. Let's do it this way. Mass of the Lincoln is 4 times the mass of the Beetle, okay, times the velocity squared divided by the radius, because the velocities and the radii are the same. So we see this is going to be 4 times the mass of the Beetle, v squared over r, or 4 times the force on the Beetle. So there's 4 times the force on the Lincoln as there is on the Beetle. Okay, there's a shorter way to have done that. Okay, let me show you. F equals mv squared over r. All right, if I have 4 times the mass, that means the force will be 4 times. You could have done it that way. You could have done the shortcut notations we've been doing in class. Now, the Cajun Cliffhanger at Great America is a ride in which occupants line the perimeter of a cylinder and spin in a circle at a high rate of turning. I can't believe they really pay for this, but they do. When the cylinder begins spinning very rapidly, the floor is removed from under the rider's feet. Why do they do this? I don't know. I say stay away from it. All right. What effect does tripling the speed have upon the centripetal force? All right. F equals mv squared over r. All right, folks, if I triple the speed, okay, I'm going to wind up with 9 times, because 3 squared is 9. I'm going to wind up with 9 times the force. Now, this sounds really bad, but you have to have a larger centripetal force or the people will fall off. Okay, the large centripetal force, actually, I'm going to show you this now. We're going to do a problem in a few minutes. Say you're spinning, okay, your force of gravity goes down. You're wanting to slide down. So friction holds you up. And the normal force, this is strange. The normal force has got to be pushing you to the side because that is the wall pushing you. Now you're spinning this way, all right? So it turns out your centripetal force is also to the center. So in this weird case, your centripetal force has got to equal your normal force, and friction has to equal Fg so you don't fall. Kind of cool, huh? Still don't recommend the ride, but it's kind of a cool concept. All right. A 95 kilogram halfback. So I've got a mass there. Makes a turn on a football field. The halfback sweeps out a path, which is a portion of a circle of radius 12 meters. Okay, so radius is 12 meters. The halfback makes a quarter of a turn. Okay, a quarter of a turn in 2.1 seconds. So how much is this? He only goes a quarter. He doesn't go the whole circle. And that's not a circle anyway. All right, he only goes a quarter of it in 2.1 seconds. Find speed, etc. So let's see. The time for a quarter of the circle is 2.1 seconds. So the time for the whole circle, I multiply through by 4 on both sides, is 2.1 times 4, or 8.4 seconds. So the period is 8.4 seconds. All right, let's find the speed. V is 2 pi r divided by the period. So this is 2 pi, the radius is 12, divided by the period of 8.4. Let's see, 2 times pi times 12 gives me 78.39, how about 75.398 divided by 8.4. Now I've left all this in my calculator. So I get a nice speed. Let's see if I can get it down here. 8.97597. So let's 96 meters per second. The centripetal acceleration is just v squared divided by r. So it's 8.976 squared divided by the radius of 12. Go on and square this. And if I can find my square button, and I get 80.568 divided by 12, or 6.714 meters per second squared. So there's my centripetal acceleration. There's my speed. And Fc equals MAC. So the mass is 95 kilograms times 6.714 meters per second squared. Now, if you've left all this in your calculator, you don't have a lot of round-off error. You get, what do you get? Okay, 95, I messed up, I'm sorry, happens, times 6.714 is 637.835 newtons. All right. Now, you could have gone back and done all of this recalculation. I don't recommend it. Once you find AC, you can just use it in this formula right here. You never have to do a problem twice. Now, if an 1,800 kilogram car, so that's my mass, rounds a curve of radius 92 meters with a speed of 3 meters per second, the wheels are on the verge of slipping, what's the force of friction? All right, so I know friction has to equal mv squared divided by r. So this is 1,800 kilograms V is 3 squared divided by R, which is 92. So this is 1800 times 9, because I squared the 3, 92. 1800, I need another 0 there, times 9 is, let's see, this is 162 with 3 zeros, divided by 92. Let's see if I get that answer. No, I'm off by a 0. What did I do wrong? 1800 times 9. Ah, right here. I get 16200. I got a spare 0. These calculators, I tell you what, they're tricky. Now 6200 divided by 92 gives me 176.0869. So let's call that 7 newtons. Remember, the answer is only worth 1 point, so if you've done all of this, you will get pretty much all of the points. Teachers make mistakes all the time. Now, a model airplane is guided in a horizontal circular path by a chord of length 16 meters. So R is 16 meters and has a constant speed of 18 meters per second and a mass of 200 grams. Now, folks, I'm trying to get you. You know you have to immediately convert this to kilograms. You know 1,000 grams is 1 kilogram. So 200 divided by 1,000 is 0.2 kilograms. I'm looking for the tension in the cord. The tension has to equal Fc, which is mv squared divided by r. So the mass is 0.2 kilograms. The speed is 18 squared divided by 16 meters. Go on and square the 18 first, and that gives you 324. So this is 0.2 times 324 divided by 16. Okay, so 324 times 0.2 is 68.4. How about 64.8? I'm not reading my calculator now. Divided by 16. All right, 64.8 divided by 16 gives me 4.05 newtons. Yay, perfect. What is the velocity of a 5 kilogram rock revolving on a 1.8 meter string if the tension, is 22 newtons? Oh, we're going to have to do a little bit more math on this one. Let's see. Mass is 0.5 kilograms. R is 1.8 meters. And the tension is 22 newtons. Okay, tension is equal to mv squared divided by r. And I'm looking for velocity. So let me circle velocity. We'll do some color changes here. We haven't done too much of that this unit. So the first thing I'm going to do is multiply through by r to get r out of my denominator. So let's see. T times r is mv squared. Those have canceled. The next thing I want to do, I want v, so I'm going to divide through by m. So what happens? Those cancel. So v squared is tr divided by m. Now I want to get rid of the square. The inverse of square is square root. So v is the square root of tr divided by m. Now let me plug my numbers in. Let me bring it up here. So the speed is equal to the square root of 22 newtons, T, R is 1.8 meters, divided by the mass, which is 0.5 kilograms. Now, folks, go on and do your mathematics simply as possible. Go on and multiply 22 times 1.8, and that is 39.6. So it's 39.6 divided by 0.5. Now, 39.6 divided by 0.5 is the square root of 79.2. Now do your square root. And I got 8.899 meters per second. On a test, let me show you how I would grade this. 2 points for the givens, 1 point for the equation, 1 point for rearranging it, 1 point for plugging in your numbers, 1 point for units, and 1 point for the answer. 2, 3, 4, 5, 6, 7 points. So show me as many of those steps as you can. Oh, I would probably give you one for the unknown. Yeah, I haven't been doing those, have I? So you get a point there. What is the mass of a satellite if the weight, Fg, or if Fg is 10,500 newtons and its velocity is 1,025 meters per second and the distance from the Earth is? Okay. So we're looking for the mass of the satellite. In this case, we know Fg is equal to big G, the mass of the satellite, mass, messed that up, didn't I? Golly, my pen's not wanting to do right. Ah, my eraser doesn't want to either. Huh. Well, let's try this. Does that work? I don't know why that's not going away, but that's okay. Let's try that. Well, you have to love computers.